Glad everybody could join us this afternoon. Customer360 meets Agent180. You might have seen this before. Don't buy anything based on what you hear here, right? No, only the announced and released products. I am Tom. This is the Tom and Cal show. While I'm talking,
thank you.
It's the Tom and Cal show. He's going to talk in a minute, and you're here to hear him. He's the technical architect and Salesforce MVP, and that's okay. We both work for Infosys. Cal Smith. Now, it turns out Cal went to the University of Ohio, graduated from the University of Ohio.
No, it's called Ohio State.
Ohio State. Oh, is that right? Is that how that works? Okay.
The
Ohio State. It's the Ohio State. Well, there was a terrible tragedy at the Ohio State. The library burned to the ground. Both books were completely destroyed. And in the remains, fortunately no one was killed, but in the remains they found a dead body. And through the magic of DNA, they were able to identify this dead body that obviously been there for a long time. Turned out it was the 1967 hide-and-go-seek champion of the Ohio State University. And his name was Calvin Smith. Was that a relative by chance to you? You don't know? Okay.
I don't know, there's too many Smiths.
There's too many there, okay.
I think you need to move on, Tom.
I'll give you a little background on the business case, the situation. We'll talk about where to start. A takeaway I'd like for those of you who might face a really big, challenging, enormous effort like we did. Maybe this, we're hoping this will be useful to you to kind of see our journey and where we started and where we got to. Cal's going to dig hard into the data architecture, the prediction model considerations. So this is where we're thinking about Einstein and these sort of things. Okay.
There you go.
Turn it up. That's what we need. Okay, let's talk a little bit about the background here. Big company, big client. I was on this project 14 months, 10 billion in sales. Now we've altered the numbers to protect client confidentiality and stuff like this, but this is real live, representative of a real live case here. Big manufacturer, electrical components, an important nuance. You know what? I was trying to hit the, I just did. There we go.
You're really doing great.
Oh, there we go. I was trying to use the spiffy laser printer. I was afraid I'd do that. Okay. This is why it's mostly the Cal show. So, okay, 80% of sales through distributors. Very important. So this is about agents. 125 to 150 customer agents worldwide. 3 different major personas we're going to talk about. The customer service, customer care persona, the product specialist persona, the inside sales persona. You're going to see how important the 20-second maximum limit becomes as we go, and an important thing to notice is that the workload, the case workload varies between the different types of agents. Their mix of how the work comes into their system lands on their desk. So what was the client trying to accomplish? Spent a lot of money on this. They were looking for, of course, the best possible customer service. Item 2 there, if the agent knows why a customer is calling, if I'm calling in why, and the agent has got to jump on that. They know an order was late, or they know other things. I don't want to steal the thunder. Why that customer is calling. Hi, Bob. Are you calling about late order? Let's work on this. Here's what I can tell you. Away we go. Now, a significant problem that we had to deal with is we had data that would help us predict, for example, orders are late. However, how could an agent possibly consume or use 5,000 lines of data in a call back and forth with a customer? So this is where we get into some of the stuff Cal's going to talk about, the predictive capabilities and the use of Einstein. The other huge thread through the entire effort was satisfy the customer, have a good customer service event. Customers tend to be happy, and that presents an opportunity to sell not only just run-of-the-mill products, but often high-margin product opportunities. Now, this is what, I was the only one in the project at the time, this is what I was presented with by this is actually a simplification, by our business user, sponsor, product owner. Have any of the rest of you ever had a customer, a business user, a product, an executive drop a PowerPoint session on you and say, here's what we want, and you go, oh my. In my job, I don't get to say, no, this can't be done, but this is what I'm thinking, is you got to be out of your mind. And you start looking at this. Some of this is easy to get. Some of this information is easy to get, but we're starting to talk about things like an order overview for a large distributor, 5,000 lines of data, quotes underway, items shipped, returns perhaps in process, overdue invoices, quality-related problems, and it gets on into the customer's buying pattern, the customer's individual preferences, histories. You know, you're looking at this, you're going, and you're going to populate this in 20 seconds. This is just out of your mind. So the challenges quickly became clear. I've kind of jumped that 20 seconds before the agent actually must accept the chat or the phone conversation. 5,000 lines of raw data. Cal came up with the tagline, you know, this was supposed to be Customer360. We'll be lucky if we get half of this done. And that's where the 180 came from. Now, our first step in doing this is, okay, big, challenging, really difficult job, really difficult requirements from the customer. Let's start breaking it down. And something I find really useful is starting to look at where does the data come from? Okay, how big is the bread box? Where are the big rocks? And right away, one of the things that you see is the items in green here all come from Salesforce. Oh, that's encouraging. We have access to that data. That's pretty easy. We know we can get that real quickly. The next big rock is the data required from SAP. Okay, we know that's hard, but the client already had a MuleSoft integration working that we were able to piggyback off, and they had some other SAP integration experience. Okay, so this is going to be hard, really hard, but doable, we think. And then they have data warehouse and traditional data warehouse kind of problems. Is the data out of date, difficulties, response time, you know, this kind of thing. But we're looking at this and we're starting to have a little more confidence, and this is starting to be a little more manageable. And as we're doing this analysis, the big question is, where do you start? What do you do? Another important piece of this was to understand the workload that the agents handle, how work comes into their department, lands on their desk, on their console. In the customer care case, so we're beginning to narrow this thing down and get to something we can actually test, prototype, do a proof of concept, actually verify that we might be able to answer the question, is this possible? Can we do it? So this customer care agent, well, 60% of their workload is by email. So, okay, only 40% is phone or chat, because those are the ones that require that 20-second response time. Okay, so that cuts down the workload substantially, what we have to do substantially, because these were 50% or so of the total agents. Product specialists, big chat workload, okay, and they turned out to be the primary, 60, 80, 90% of their work was either chat or phone. Very little email, and I should move on a little bit, so this is just a little easier to see. And you can see some of the other attributes here of their work, understanding their work, what they were selling, and my favorite, hot leads. A big part of their job is to identify hot leads, capture them, and move them on so that our intrepid inside salespeople can follow up. So we learned pretty quickly as we're looking at the inside sales agents, 40, 50 out of that 150 of these agents, 40% of their workload is phone, and and a significant amount of this is outbound calling. So as a practical matter, they weren't going to have a lot of need for this console that we were trying to develop, the 360 console. So really, we were able to hone in on, particularly from a prototype point of view, this is going to be the primary persona user that we needed to meet their requirements, see if we could make all this work. And we this was a bit of a breakthrough. This took several workshop sessions with the managers, actually the SAP managers. The two ladies in particular helped us, and we put this stuff all over the conference room, and we were looking at the question, okay, there's data in the SAP, you got an incoming phone call, you got an incoming chat to an agent. There's data in SAP. What could possibly be retrieved and useful to the agent? And we boiled it down to just these 5 items, as you can read there, and we had another catch-all category for things, everything else. Okay, so we've gone from this enormous undoable thing down to, actually, it turns out, if we can predictively say this customer is probably calling because of a late shipment, for example, or a quote, this is useful. We could prototype that, and we did. I'll mention one last thing before I turn it over to Cal. Very helpful in a big initiative like this to identify your project killers. What could kill you? And in this scenario, it was just glaring. It was the response time for the integration data to be able to do something useful in 20 seconds. Cal?
Thank you, Tom. Well, first we'll see if, there we go. We're going to talk about the data architecture to begin with. As Tom mentioned, they had just done a MuleSoft integration, and he also talked earlier about SAP being one of the primary sources of data that wasn't in Salesforce. This particular company did all of their quotes in another app that wasn't in Salesforce, and then they were working with MuleSoft to bring those quotes into Salesforce. So you might say they were doing it backwards from our standpoint. And the orders, of course, were in SAP, even though we all know from our standpoint, you relate orders to opportunity. Shipments were tracked, again, in SAP. Opportunity line items are always scheduled in back end, but they do need to be updated from opportunity. Your basic ERD here. This is what the data integration looked like. Essentially, the plan was make a call out to SAP, bring it back, combine it with the Salesforce data, send it off, do your AI processing, and from that, display what you need to the agent. That's the super high level. Oops, went too far here. On a little lower level, this is the services that we had in place. The data lake is shown there simply because that's where all the data existed that we needed in order to create our model. Our deck is going to be available. We're going to post it in a link from our listing from where you registered for our our session. So, prediction model considerations. How do you take all of this together? And how do you do this when you've got all these different objects? Not an easy thing to do, and there's a lot of different considerations. And I want to talk about this. We're talking about trying to take and predict 4 items and actually a 5th. And there's a lot of different things that aren't inherently obvious about how you do this. And it begins with the frequency and distribution of how these issues occur, the things that you're trying to predict. If you have one issue that is a whole lot larger than all of your other issues, then trying to predict the other issues is going to be extremely challenging. because statistically speaking, the average, the odds are it's the one larger item. So it makes it impossible to predict all of your other items. So your predictable items must be of a similar scale and variance. And that's why we have our other category, because anything that's within the noise level of your largest category, which by my estimation is approximately 22% of its mean, is basically has to go into the other, because you're not going to be able to predict it. And so I'm going back to some basic statistics here for those of you who, I don't know what everyone's level is at here, but this is a normal distribution curve. And the lines here show what a standard deviation is. 3 standard deviations includes 99.7% of your data. 95% fall plus or minus 2 standard deviations away. So, and your data, your source data, is presumably going to look something like what you see on the left-hand side of your screen here. And this is real important. If you don't have data that looks pretty well concentrated near your mean and then spread out away from there, then you don't have a Gaussian distribution or a normally distributed data. Now, are you lost and in trouble if you don't? The answer is no. But you do need to know whether or not you have data of this nature and what your nature of your data is. We're talking about multidimensional patterns here. We have data here. I put on the long axis here, account size in dollars per year. We have data that encompasses many different dimensions. And dimension is a term that's used in Einstein analytics for an attribute that you're going to measure. So we're not talking about just 3D type of thing. We're talking about potentially an infinite number of dimensions. Here, if we took all of our data and looked at it in multiple spaces, you'll notice that there's a bump. What this does is it tells us that there's a positive correlation where in this account size here, there's an affinity with this account size that we can use to our advantage in making predictions. And here I'm going to show you some examples. When you have that, someplace else, you're going to have a bump in the other direction. Because when you have a positive correlation, and knowing that you have a mean, there's also going to you have to have a negative correlation someplace else. So on the left-hand side, you see attribute A. I'm just going to generically call it that. It could be shipments, and attribute B could be quotes, for example. You'll see that we have, in the one case, 1 positive correlation, and then the right-hand side, we have 2. And similarly, with the inverse with negative correlations here. So when you're building these models, you want to look for these types of things, because they make your prediction model more accurate. It doesn't matter why these occur. It's the fact that they do occur that's important. And here are some more examples of them. These would essentially be in product family. You may find only one that has a negative, but in the others you would see other offsets. A, B, and C here. And here's some examples of the kinds of correlations that I'm talking about. Customer size, as we started with in terms of gross revenue, or total units. It could be measured in any type of thing. Product categories, the industry, customer location, that's a really big one. And I'm going to give you an example of why. You may not have problems, for example, with your customers who are local to you or on your geographically nearby, because you don't have any issues shipping your products to them. But put them on another continent, you get breakage, you get issues with rail shipments, other things like that, vibrate things apart. I know this from having been in the auto industry. That was one of our biggest problems, was just simply shipping things to assembly plants. They fall apart before they ever get put in the car. So customer location, number of products, I could go on, huge list. So with a multi-object model, you want to look for correlations. If you find them, you combine all your data, and if the correlations are found, then you're going to want to segment your model, meaning that you break these segments out as and you adjust for them. And here's an example. Again, looking at a normal distribution. If company C has 17% of all the cases that you get, in company A here, you can see where their average is at, you're going to want to know this, and you're going to want to account for this in your model. Even more importantly, you're going to want to validate that company C's data also fits a normal distribution. Because if it's got data that's skewed, then that's where you do have a problem. These things also need to be able to respond to time. If you've got a specific issue or instance that happens with a particular problem, quality problem you may have had or some other issue, your model has to be able, there's going to be a responsiveness type of thing. One of the things you're going to need to be able to test is how quickly does my model learn and adjust for these things. So as you look back through your data, you're hopefully going to see a fair range of different types of things with your different customers. Because if you don't, then it's not necessarily going to have what I'm going to refer to as elasticity. So essentially what we do is we create an object model here, or a data source object, that's a composite object that's a result of an aggregate query result. You have too many objects here to put them all together and individually send them to Einstein. You don't need all the fields from all these different objects, but they have relationships with each other. So what you're essentially doing is creating a composite object. To incorporate machine learning, there's a couple different ways to do this. For those of you who've worked with Einstein, you know that one way of doing this is regularly refreshing your data on some periodic basis. That's how, in essence, it learns, or it can learn. You can also, say, take the case object or something like that and add fields on it to your predictions that are Booleans. So there's a true, false, and that's why I call them truthy predictions. And they become learning records. And you add them to your model. My preferred method is to create an object for your predictions, which you then incorporate into your overall object model. That initially it's not going to have any data, but ultimately it's used to adjust the AI, and it becomes the incorrect predictions that you get become what I refer to as significant records. Because these are the records that the AI learns from. These are the ones that tell the AI that, hey, you had these set of conditions, and yet you predicted outcome C, when in reality, the outcome was A. So it creates a feedback loop that the AI actually learns from, because it knows that under these precise conditions, its prediction didn't work. And there's no need to refresh your model. So we've taken you on a journey here of what we were given from our customer, what their business model was like, what the needs of their agents are. And we've talked about how to create the model for this, how to process it, how to bring the data in, how to send it to any kind of, and I don't think I've emphasized this, this doesn't have to be done with just Einstein. This can be done with IBM Watson, can be done with AWS, any kind of AI predictive model that you want to use. You're not limited to just Einstein. I mean, hey, Salesforce has been my, is my living, but there's a lot of competition out here today in the AI market. So, you know, I want to say that this isn't an AI, this isn't an Einstein-only solution. Now, from our standpoint, because all of our data was already on the Salesforce platform, and because we had to get a response back within 20 seconds, it didn't make sense to push our data out to AWS or someplace else that was off platform and then wait for a response. But for others, it might. So for us, it seemed like a no-brainer. So keep that in mind as you're architecting these things. So I'm going to turn this back over to Tom, the big guy over here, and he'll tell you how we're going to set the agents up for success with the results that we're getting.
So how do we make use of this? How do we deliver on this promise and what we were asked to do? Gauges is one good way to look at it. And here's what the kinds of things that we had talked about: quote, schedule, late shipment. We're all familiar with red, green, yellow sort of indicators. A lot of this comes native in a lot of software. Here's the payoff and what we were actually able to prototype. So we actually delivered 3 demos as we were doing our agile sprints. The first part of this was pretty easy to do, well, relatively easy. Incoming phone call or incoming chat, there's enough information there, the IP address or phone number, or various things, that cookie-related stuff, that you're able to actually populate who this is coming from. We knew that it's you know, going to be Bob Jones, Appliances RS. We knew who his bosses were, credit limit $20,000. That was easy. So that was prototype 1. We were able to pilot that. That was, the client was really happy to see that. And then prototype 2, we took a shot at expanding and going beyond this, and that was kind of marginal. But then finally, prototype 3, we were proof of concept. Prototype 3, we were able to actually demonstrate an incoming call, and within incoming call or chat, within 20 seconds, be able to give an indicator on the console, you know, to the agent. 87% likely that the quote is overdue. That's why the customer is calling. You run out of real estate real fast here. And we prototyped this, roughed it up, and it was quite rough, intended to prove the concept. That was our charter. We wished we had a finished product to show you all this demo and live and working, but our job, which we met, was to be able to demonstrate an 87% likelihood in this case. Quote was overdue. We had additional information that was very useful to the agent to know. So if I'm the agent, there's also a chance that we've got a shipment overdue. Not likely that it's an order change needed, and it's not likely that it's a return problem. That return problem was one of those things that was buried in the other column. So this was the payoff and the prototype. And for those of you that do these kind of big projects, what we realized when we demonstrated to the client, what the client realized was to take this thing all as far as they wanted to go, it was going to be a lot more expensive than originally thought. So the project was on hold, and that's why we didn't get to finish all of this. So I think of it as a very successful initiative to determine that within that 20-second window, we could provide useful data based on analysis from SAP that help the agent serve the customer better, provide the opportunity for additional sales, the overall goals of the project. Did you want to speak to this?
Yeah,
and
more importantly is that what this also allowed us to do is, what you'll see here is that we pop up on the screen, open opportunities, and those that had related quotes or quotes due, so that the agent is immediately set up with a new case screen in the right context for them to start working the case. And that was really where we were trying to head to begin with, was so that whenever an agent gets a case and they know what type of case that they're going to be working on, they're set up with the right components, visible and populated with the data about their customer. This is the same customer that Tom was showing previously on the prior screen that he was talking about. And there's the opportunities related to the account and the quotes that are due for that account that the agent needs to work on in order to finish working that case. So you'll notice the console view control that's shown up here. If you come to our presentation on Thursday at 2:30, I'll give a pitch for this, I guess. The console lends itself to conditional visibility on a lot of components. And you can actually create different views and change these with the click of a button. So that's part of what is some of the content that's included in our presentation on Thursday, is in terms of planning for agent productivity. So I think at this point, we're going to move it on to some resources. These are Trailhead modules that may be of interest to you that are related to this presentation. And with that, we thank you for coming, and we will open it up for Q&A.